Hello, welcome to Easy Crypto with Nimiq. Nimiq makes crypto easy to use for everybody, and we have this series to explain more about it. I am your host, Richie, and this time we are going to be talking about Nimiq 2.0 and the next steps. Here I am with Philip, technical lead of the team, and also with Sebastian Dittel, also known as Basti, a blockchain developer of the team. So guys, welcome and thank you for joining me.
Thanks for having us.
Thanks. So what is Nimiq 2.0 for people that are just like getting to know about this?
You want to go ahead?
Sure. Nimiq 2.0 is our new version of our blockchain protocol, and the primary thing that it introduces is it switches the protocol from a proof of work protocol to a proof of stake protocol. So we're introducing staking, and that has a bunch of advantages. So first of all, proof of stake is much more energy efficient than proof of work is. So the blockchain protocol is going to use a lot less energy, be much more green and environmentally friendly, energy efficient. And so that's one of the big advantages of switching to proof of stake. Generally, proof of stake is not only more energy efficient, but also a lot more efficient overall. So we can get better throughput, better TPS, better performance of the chain by moving from a proof of work to a proof of stake model. But also staking is going to allow users of the chain to use their coins in order to secure the network, stake them for a validator who then can use the stake to vote on blocks and to secure the network, process transactions, and stakers are going to be able to earn rewards by participating in this staking mechanism. So those I think are the primary advantages and the primary new features that we're going to be introducing with the 2.0 chain.
Yeah, to add to that just a little bit, like one of the interesting parts about being able to stake for a validator is that formerly in proof of work, you actually had to run a miner yourself to earn these rewards, which obviously you need the hardware for, and you need to like make sure and maintain this stuff. Whereas in proof of stake, you no longer have to. You can basically just delegate your stake to a validator, and he then in turn is going to do all this work for you. So that is really making earning rewards and producing blocks accessible to pretty much everybody. And that is also a very nice thing to have in this new protocol.
And in this case, I think also it's important to note that because of the unique properties that the Nimiq blockchain has, namely like browser nodes, for example, and super fast transactions, then it is not a copy paste of another blockchain, right? Everything is made from scratch, except that we reuse or we utilize some libraries from the common blockchain space, like libp2p. So we are building like our own stuff here.
Oh yeah, this is definitely an original blockchain that is not a fork or anything like that. So we are building this basically from the ground up, using obviously some of the best practices to not reinvent the wheel like everywhere, but the protocol itself is an original protocol designed by ourselves.
Okay, and where are we at right now? How would you explain like the progress towards 2.0? Where are we at?
Maybe if you also motivate just the previous point just a little bit. Sure. I think also one of the reasons why we are actually pursuing our own implementation and not just reusing an existing one is that one of the primary or one of the key objectives that we have is to allow wallet apps and clients and users to directly interact with the network, right? So we want to have a protocol that you can access without having an intermediary that allows you, access to the underlying network, like it is the case with, many blockchains that have a, distributed and decentralized design underneath. It is still very difficult for client apps to actually connect to the network directly and become like a first-class node of that network, and that is one of the motivations why we are doing our own protocol in order to enable this particular aspect.
Yeah, something like maybe most or maybe all cryptocurrencies are decentralized all the way to the server node. We are decentralized all the way to the wallet.
Yes.
Yes.
I think that's a pretty big distinguishing aspect that sets our protocol apart from others. Of course, others also care about light clients and wallets, but I think we are really taking it all the way here. Also with the browser nodes, which are another example of this particular direction that we are pursuing there.
Yep.
So, okay, that being said, where are we at right now? Like, what are the main challenges right now that we're working on with Nimiq 2.0?
Okay, maybe let me throw some in there, and then Basti can add some more. We have a full implementation of the protocol, but we are still making it more robust. That's basically kind of where we are at. So everything is implemented, the chain runs, it works. It can process transactions, our validators work. The network is also reasonably fast, a lot faster, orders of magnitude faster than our original implementation. And the main challenges that we face right now is making it so robust and so stable that it will basically, no matter how faulty or malicious certain network participants behave, the network and the protocol is always able to continue producing a chain and can recover from pretty much any state and any behavior that is sort of covered by our security assumption. In contrast to proof of work, right, where every miner is basically his own his own participant that can produce blocks and process transactions just on his own, without having to interact with other parties on the network except to gather transactions. Here in our proof of stake model, we have a lot more collaboration between the key entities that secure the network and that process transactions, namely the validators, and therefore it is much harder to get this right to a point where when validators come and go, when validators behave faulty or maliciously, we can still continue with our protocol and continue producing blocks, even though this is a very collaborative yet distributed process that we are going through here, right? So it's a whole different story than coming from the proof of work world.
Yeah, definitely. So currently, I would say basically the ongoing process that we are currently doing is have our implementation run and perform, and then to basically find out when it breaks and why it breaks, and then to fix it and basically make it as stable as we can absolutely make it to withstand pretty much any scenario being thrown at it. And that usually involves digging through like lots and lots and lots of gigantic logs to try and figure out what is actually happening. And then also obviously that comes also with the idea of like improving tooling and these kinds of things to basically enable us to find these issues more quickly and then also ultimately to resolve them more quickly. And there's also like being a lot of work being done in that regard to enable us to basically create these things quicker than before. And I think we are actually on a pretty good way to like achieving these things. And that is, yeah, I'm fairly confident.
And what are the biggest challenges so far? Like what things kept you up at night more or gave you like the biggest headache?
Well, I think there are multiple challenges, right? So I think generally one sort of area that we are looking at is of course chain performance, right? That's with coming from a chain that can do pretty much like 12 transactions per second with a block time of 1 minute, things are nice and easy and slow, and
you have a bunch of time.
Exactly, you have a bunch of time for everything. You're not in a rush. A block a minute, that's easy and chill. But now we are more talking about 10 blocks per second, right? I mean, depending on what the load of the network is, and that definitely introduces new challenges, such that we can make sure that nodes can actually keep up with that extremely fast-moving chain. And even if they disconnect for a while and miss some of the stuff that was happening on the chain, that they can properly catch up to the state again. Also, another challenge that comes from this is if we are so fast, then our chain state can also grow pretty quickly, right? So if we can process thousands of transactions per second, and we actually do that, then our database of stuff that has happened basically grows very quickly, much quicker than it used to grow, right? So that also comes with some additional challenges and some issues that we need to address there, and that we need to solve there. I think that's basically sort of one area, but we are, I think, already doing. We are already on a pretty good state with that regard. So performance is not top of the list right now. I think another challenge, something I already hinted at earlier, or that we hinted already at earlier, is the fact that block production or transaction processing is now moved from being a process that can be run by one miner individually on his machine in his node. That is now a distributed process that involves communication with a lot of other entities, and it's basically a distributed computation. And reasoning about this distributed computation, if this is happening across 20 or more nodes, and a lot of computations happen in a very short time, that makes analyzing what is actually happening under the hood more challenging, also because there's so much data to sift through, and that we need to post-process in a way such that we can understand and reason about the block production processes, and why some things get stuck or don't work as quickly as we want them to be, or behave the way that they behave under certain conditions. So that is definitely also another challenge that we are looking at here. The distributed nature of the system, combined with the extreme high throughput and the large amounts of data that every run produces, that's definitely also a lot different than a block a minute, and everybody does that on their own.
Yeah, the collaborative process sort of to produce blocks also like introduces a wide variety of network messages that previously didn't exist, which now need to first be delivered in time to specific nodes, and that also like creates some synchronization issues between those nodes. In particular, when thinking about like 10 blocks a second, that is actually fairly low. And the network delay is also adds to that. These things also need to be delivered in time, and that definitely is also a little bit of a challenge. So yeah, it does change the landscape of how this protocol works quite drastically, I would say, and that obviously introduces some things to be taken care of.
Mm-hmm. And in terms of we're talking a little bit about browser nodes and like all the way decentralization kind of to the wallet and lowering the barrier for people to connect directly. What are the things, or like what are the differentiators in terms of like design of our chain? For example, no smart contracts to make things simpler. Also the decentralized all the way, maybe those things I think when it comes to design of the chain itself changes, right?
So generally, we need to strike the right balance between performance and decentralization, right? Because ultimately, at least in a sort of monolithic blockchain design where every node validates everything, naturally, the more throughput you have, the more transactions you are processing per time unit, the higher the load on each individual node, right? So, for example, we can see with Solana that they process a tremendously high amount of transactions per second, but at the same time, they require very strong machines, very strong, very high computational resources in order to actually participate in the network. Special hardware, insane amounts of RAM, in order to be able to run such a validator. So that naturally leads to more centralization, just simply because the barrier of entry to become a validator is much higher. You need to invest a lot more into hardware. You cannot just run this thing off your home computer, pretty much, right? So that's one area where we are just trying to, strike the right balance here between having reasonable throughput, but still having hardware requirements that are low enough to allow ordinary users to also run nodes on the network. Then another aspect that we need to take into account is that if we want to have light clients that can directly access the network, we need to be able to provide them with a very succinct proof of what the current state of the network is, such that they can, validate the state of the network, their own balance, transactions that have happened themselves without having to rely on another gateway or another intermediary that helps them with that.
And also without knowing the entire chain, because they don't.
Exactly, without knowing the entire chain or downloading the entire chain, because that's obviously infeasible for a light client, right? And that also then comes with some implications for the design. We need mechanisms to succinctly prove the chain state. The fact that we don't have smart contracts, I think, was more of a conscious design decision that we made very early on in the project, right? Because our focus was on, doing payments in a decentralized way, as easy as possible, and this sort of as easy as possible approach, making this as simple, having an approach that values simplicity, the smart contract direction, general purpose blockchain did not really fit well with that goal. So that's why right now there are no general purpose smart contracts supported on the Nimiq blockchain at this time. However, we also do have smart contracts on the chain, right? They are just hard-coded and not general purpose, cannot be developed by third parties. And I think in the future we are probably going to have a lot more of those hard-coded smart contracts to have more possibilities, more options of things that I can actually do with the chain on chain. But at this point in time, there are no plans to ever turn them into a general purpose blockchain like Ethereum with programmable smart contracts, simply because that is not the focus that we have in mind when we want to do easy payments.
Yeah, it makes more sense to maybe let them do that thing, let them do their thing, and then be like interoperable in some way, like HTLCs we have right now could help maybe some connection some way in the future, but it's not our focus. And in terms of like next steps, talking just like 2.0, like what are the next like challenges? What are you like now going back to work? Like now after we finish this podcast, you go back and you're like, you have to face this bug, this thing.
Like you want to have a like very concrete example for that? Okay, so currently for some reason the validator gets stuck producing a certain block type. Not all the time, just like rarely, very rarely actually. But once is enough to stall the chain, so it's needs absolute fixing. And that has to do something with the communication between validators that at some point can turn into a faulty set of communication. And that is what I'm currently dealing with and trying to fix. It's actually not that easy to find, and it's actually quite time intense to like look through the logs and find these like specific bits of communication that I'm looking for to identify what actually goes wrong here. But this is just like one example out of some, which basically always allude to the stability stuff, to make the chain perform regardless of circumstances. And this is like the example that I'm working on today. But yesterday there was another one sort of similar to that. So enough work for now.
Okay.
Yeah, so that's very, very good example. Basically validators going away, which then leads to some identifiers of validators changing, and then we cannot apparently communicate with those validators anymore because their identity has changed and something goes wrong with the mapping there.
Right.
Other issues that we are looking at is some network-related things. So, for example, after we restart validators, sometimes re-establishing network connections to other entities or other validators in the network has issues, which then down the line leads to certain requests not being delivered correctly, which can then prohibit a node from actually syncing up with the network and then falling behind and not being able to participate in block production anymore. So that's another thing that we are looking at. But also we are, as Basti mentioned earlier, also improving the tooling, improving the workflows that we have in order to identify and resolve these issues. So I mentioned earlier that a single run of the DevNet that has 20 nodes and produces 1 million blocks that can easily produce gigabytes of data. And in order to efficiently assess conditions that we see in the DevNet that we want to follow up on, we are now setting up better tools to process this data, not having to scroll through log files that are 100 megabyte large, but to instead have nice visualizations of these runs, so that we can basically at a glance sort of see what is going on, and that this is also going to be something that we will later on use to actually monitor the live system and to identify problems that might occur in the live system. So generally setting up better monitoring, better tooling to gain better insights into what is happening in the network.
And the gigabytes of data is basically gigabytes of log data only. So obviously 1 million blockchain produces quite some data on its own already, like just in database size. But that is not what Philip was alluding here to. It's the log data that is actually quite large and very, very hard to dig through if you're looking for something very specific.
Well, guys, really complex, but really interesting work as well. I know everybody is super excited about the realization of this work. So keep up the good work, and thanks a lot for joining us.
Yeah, thanks for having us.
Yeah,
Thanks, Richie.
Okay.
Yep. Take care. Bye-bye.
Thank you.